So dilation. All right. We're going to talk about how to draw them and talk about similarity. So the idea of dilation, this is a lot of words. What they're saying is this, okay? When we dilate something, there is always a center of dilation and then an amount that something dilates. How much larger? Now, other examples that you would know of dilation is actually like you're staring at one right now. For example, if I do this, if I put my hand up here, what happens on the board? My hand got bigger. The center of dilation is here. My hand is the object, and then it's getting bigger on the board. Does that make sense? That's another image of dilation. When you actually take a picture on a camera, okay? When you actually take a picture on a camera, the image comes into the camera and comes out on the other side, technically like on the screen, and it's smaller unless you took a big picture of something really tiny and then it's bigger, right? So that's another idea of dilation. Now, that one's tricky, and I want to make sure we understand it. And this is kind of lost on more our day and age. But when you actually take a picture, does anyone know originally what would happen on the film? It's up. We don't have film anymore. Okay? If you have here's your camera, on a little tripod, little flash bulb, and it's taking a picture of something over here. How would it actually come out on the film? Okay, it was dark, and they had put it through chemicals to kind of get the colors to come out, the light to come out. You don't know. It actually is the same way your eyeball works. Does anyone know how your eyeball works?
It opens up.
Everything's upside down. Okay. So right now, as you guys are looking, actually in your eyeball, right? Okay. The floor is up here, and the ceiling is down here. Okay, but your brain knows that's not right. If I wanted to, pat Davis on the head, I wouldn't go like this. Because that wouldn't make sense. And my brain knows that. This is not the world we live in. This is how it works. And so between your eye and your brain, it's flips everything upside down. So in cameras, what used to happen is it would burn an image, right? It would let light in and burn the image onto film, and it was upside down. No, it didn't matter because all you did was go like this with the actual film, right? You just turn it the right side up. Okay? Technology, so I want you to understand the marvel of this, is when you take a picture or you look at a picture on your phone, between the lens and the display, what's happening? Yeah, there's a computer in there saying, take everything that the lens sees and flip it upside down. So we're going to have a point of dilation. Okay, where is it dilating from? Okay, how much bigger or smaller is it going to be? Okay, and then you can kind of get images from that. So we've got this. And what we're going to do is we're going to take this, and I have a ruler. We're going to dilate from this point. I just wanted to show you an example. Okay, I'm going to take this thing, and I'm going to do it with a scale factor of 2. Okay, and a scale factor of 1/2. That's what R represents. So, show you what this looks like. What I'm going to do, just try to walk you through how you do a dilation, is I go from this, and I put 7 just so I could kind of measure things. This is actually, how many centimeters is this? Can we kind of see that okay? Can we turn off the 2 closest, I think, to us? There you go. Okay. So yeah, was everybody okay? It's 5 centimeters? Yeah. So if I do a scale factor of 2, where is point D going to end up? Instead of 5 away, it's going to be?
7. 3. 2.5.
Okay. Think of something. I want to make it twice the size. It's going to be 10 away. Does that make sense? You're doubling that. So if this is 5, I'm going to go 10. So I'm going to put it over here at 17. Is everybody okay? Yeah. 7 plus 10 is 17. So this would be my new point, D prime. If I do that from to point C, I'm going from here. I'm dilating from this point. Think of this as my flashlight, and I'm casting a shadow. Okay? So here's the flashlight. The light is here. It's shining this way. Okay, so now it's 7 to 15. How many spaces is that? 8. So I'm going to double that, and I'm going to go 16. So 7 plus 16 is 23. That's C prime. Okay, and I can draw that line. Okay, there's that. Okay, now this one you can't do with the like ruler that you have because it's like glued to your paper. Okay, but like I'm going to take this one and I'm going to move it, so it's going to go this way a little bit. Okay, again, I know you can't necessarily do this. I'm going to line it up this way. Make sure I get that pretty accurate. Okay. And I'm going to go this way. So let's make this like way, way, way easy. Let's go 0. Okay, 4 centimeters, double that, you get 8 centimeters. Okay. All right, and that'll be A prime. And then to B, it's 7 centimeters. So double that, and we get 14. And that would be B prime. And I get this like, oh, sorry, try to stay pretty straight there. Okay, so I get this shape. Yeah. It's twice the size. Same shape, just bigger. Yeah.
I don't understand how you're getting double numbers.
I'm measuring the distance from the object that I'm dilating from, this is my center, to here. Right? And if my scale factor, so this distance right here is 5. So if my scale factor is 2, then the distance from here to the new D is double that 10. Does that make sense? So if I'm going to do that now with this scale factor, what am I going to look for? Instead of 5, I'm going to look for 2.5. Half of that. Okay, to make it smaller. There was another hand. Yeah?
Alright, so if like R8 was 2, if it was 3,
It'd be triple.
Yeah.
Yeah. Absolutely. So let's take the blue one. Okay, so again, the distance from this dot, that's where I'm dilating from, to point A is 4. If my scale factor is 1/2,
2.
point A. Or point B. So what is your question? Ask me, don't ask her. This is this point right here. It's 4 centimeters. That was 8 centimeters. The last time, because I doubled for this, right? So, yeah.
So like for the last one, how'd you get like 23%?
Because my actual, like, to be clear, let me back up. This was like this, and the way my ruler was laid out, because it's how it's laid out on your paper, right? The center of this dot was actually at 7. So this distance from this dot, to C was 8 spaces. That goes 7 to 15. Is everybody okay? 15 minus 7 is 8. So what if you double 8, what do you get? 16. What is 7? Because that's where I'm starting, is at 7 plus 16. Well, that's 23. Okay, that's why I'm using the weird numbers, because I was just trying to show you with the ruler you had on your paper. Okay, so yeah, if I move it, this makes things a little bit easier here if I do it this way. So if this is 5, half of 5 is 2.5. Half of 8, that's this distance, 4. Okay, again, I'm going to tilt this up so we go this way. And then this one is 4, half of 4 is 2, and then half of 7 is 3.5. And again, you got all these points. So there's A double prime, B double prime, C double prime, D double prime, and C double prime. And you get this. Okay? Now if you're paying attention and you know pop culture, then you actually recognize something right now.
Oh.
This is the Adidas logo. So you got something like this. What did the half thing do to it? What did the scale factor that was 1/2 do? It made it smaller. If it was above 1, it made it bigger. What if it was 1? What if the scale factor is 1? It's the same size. That's what we call congruence. We've already talked about that. Okay? And then you've got a negative one. And I wanted to make sure this is really why I have my 7 here, is so we can kind of see this. Okay? So if it is a negative number, what it does is, like a camera does, it pulls it into the other side. So a negative 1 is going to take this distance, which we've already established. This distance is 5. And it does it on the other side in a straight line with it. So we would go 5 on this side. Okay? And then if this one is 8, and then I'll have to move this over. That one's 8, then I'm going to go 8 on this side. That's going to go that way. Now notice what happens though, is to keep my line straight here, going this way, if I can get this to work out. Okay? Here, we said it was 4, so I'm going to go 4 this way. I'll be here. And then the other one is 7, so we'll go 7 this way. What happens to our object itself? Yeah, it flipped over. And this is what we talked about. This is how your eye works. Where A is down here, this would be like triple prime, and D is up here. Again, this is actually how your eye works. Okay? If you've ever done it. Did you guys, like, in science, have you ever studied the eye?
Yeah.
Is that, when did you do that? Last year? Okay. So, like, kind of in the design of the eye, and the way, like, you know, it's, you've got, like, your things here, and then there's, like, the center of focus here. It kind of spits it out and then goes back to the back. So the person standing here at the back of your eye is actually... Oh, I did that backwards. It's this way. Upside down. Okay. What?
How does that happen?
It's the way, again, it's the way light reflects and where the center of focus is in your eye. Right? That basically the image is coming in and light is bouncing around and it comes in this way and then goes this way and goes this way. Right. So some of these, again, this is meant to be pretty easy. They just want to know, like, okay, we're going to dilate something. My scale, the center is C. My scale factor is 1/3. So what does that mean about my object? Is it going to get bigger or smaller? It's going to get smaller. So we can look at these. L primes are my copies. All the prime ones are the copies. So you're like, okay, this one got smaller. This one got smaller. This one got smaller. And then this one is a negative. So I know, like, this one's out. Okay. How do I know it's a negative? Because it's flipped and it's on the other side of my point of dilation, right? So it's one of these. So this is how we figure this out. You can do one of two things. You can measure this distance and make sure that this guy is 1/3 of that. Is everybody okay with that? It should be 1/3 of the size. Or you can measure the distance from C to one of these points and then C to the original and make sure that's 1/3 of the distance. So we're comparing the blue lines to the green lines, and they should always be, in this case, 1/3 of the size. Okay? If you guys were to guess, which one would you say is the answer? So A, B, or C? Okay? We're saying C. So that's what I heard. So if I took this and I took 3 of these, you know, not quite. Okay. It's kind of hard to tell just by looking. Okay, so it is this one, and we would use a ruler to actually help us do this. Okay, like pull out a ruler, measure the distance. That'll make it a lot easier. Okay. All right. So to create an illusion of a life-size image, puppeteers sometimes use light sources to show an enlarged image of a puppet projected on a screen or wall. Any magicians out there? No magicians. You guys are missing out. All right, Jonathan. Okay, there's this thing in not just in magic, but called Pepper's Ghost. Okay, and Pepper's Ghost is this. You use this illusion. If you've ever seen, there's these toys, and they look something like this. They're kind of like this, and you put an object down here, and then it makes it look like it's floating up here. Have you guys seen those things? Okay, yeah, it's like a hologram. Okay, it's really interesting. So you would take, like, let's say you took a piece of candy, you know, and you put it here, and then somebody would come over, and it looks like it's up on top, and they would go to grab it, and then they would grab nothing. Okay, and what's happening is inside of here, there's a bunch of mirrors and lights that basically project the image up here. Okay, really fun, interesting, you know, just to watch people go like this, and then. Okay. So that's kind of what's happening here. You have a light source, you have this, and then all of a sudden it'll appear bigger up here. In the Haunted Mansion at Disneyland. Do you know the dining scene?
Yeah.
Okay, that is using Pepper's Ghost. So basically there's a giant piece of glass there that you could see through. Everybody with me? So you could see the table down below. And light is projecting onto the piece of glass all of the dancing ghosts. Does this make sense? then what you're actually seeing is it looks like, because it reflects it, it looks like they're dancing in that space. But really it's just a projector and a big piece of glass. Right? So people would do this to make it look like there was someone on stage. Like, this is what magicians would do. But the person was actually off stage. But the mirror reflected with the light would make it look like they were standing there. Kind of, again, weird. It's interesting if you look at the dynamics of how it works. So this is this one. So notice that this is actually two triangles. You've got a triangle here and a triangle here. Okay, so these are our two triangles that we're looking at. Okay, and it says, suppose the distance between the light source and the puppet is 24 inches. Okay. All right. To what distance, P to P prime, should you place the puppet from the screen to create a 49.5 inch tall shadow from a 9-inch puppet? So can I break this down just to help us out? Okay. You got 9 inches, 24 inches, compared to 49.5 and this distance here. Okay. How much is this whole thing? All the information's there for you to tell me and answer. Okay, it's 24 plus x. Is everybody okay? Like 24 plus x would be this whole thing. So if you want to find x, you could put 24 plus x. I'm going to do it this way. I'm going to put y here for a minute. Okay? And then we're going to find y, and then how do we get x? If y is this whole thing, and you subtract 24, you'll get x. I kind of tend to like to do it that way, so my equations are a little bit different. Now, here's what we do with these. And you guys did this, I know you have before. If you have these two triangles, 24 and 9, and again, I'm calling this y, and 49.5, oops, sorry, 49.5, we're going to do this thing called a proportion. I keep doing that, 49.5. This entire chapter, almost every single problem will be set up like this. How do we solve these? Okay, we can cross multiply to solve. Now, I'm not going to cross multiply, and I don't think you should either, because you guys are really smart. And we get in the habit of just doing things and just doing them. Like, fine, cross multiply, okay. Right? But can I just, like, can we think for a minute? What are we trying to solve for? We're trying to solve for y. And x ultimately, but y, right? Can we, like, pretend this was not a fraction? How would you solve this? You would multiply by 49.5. Is everybody with me on that? Like, if this was just 82, you would multiply both sides by 49.5 and you would get your answer. Why would we cross multiply, get a number, and then divide by 9? Now you've created how many steps? Yeah, like, you're cross multiplying, okay, which, I mean, again, that's a step, and then at least you're dividing. At least you're doing 2. Depends on how many, like, really simple. Multiply both sides by 49.5. 49.5. Y equals, and then you go to your calculator and you punch this in. Okay, everybody with me? 49.5 times 24 divided by 9. Okay. If you want to be really careful and you put parentheses here, didn't do that. Your calculator can handle it. Right? And you do that and you get an answer. What's y? Somebody help me out. I need to see this. I'm fine if you use your calculator afterwards. Okay. You cross multiply. Or you do it this way. You got to show me your work, so this is easy work to show. Yeah.
122.3.
Okay. You okay with that? Pretty okay? If it's easier, one of the things you can do if it makes it any simpler is simplify your fractions first. You could have done 8/3 if that makes it better for you. Okay. Sometimes students like to do that, right, to simplify their fractions. Okay, so then we wanted to find x, which happens to be like, this part of that. So x equals 122.4 minus. Yeah, how much was this part? 24. Okay. 98.4. Okay. Yeah.
Well, y for me equals 130.
132.
Yeah, I think it's 132.
Okay. I got that too. 132. That makes it nicer, doesn't it? 132 minus 24. 108. Okay. Oh. Jeez. Okay. You good? This is like the most involved they're going to be, where you got to think through a little bit of the dynamics. But really, you guys, like, this is why I breezed through this chapter a little bit, is like, the entire chapter, all of your math is this. Like, be suspicious if you're not setting up proportions. Fraction equals fraction. Okay? All right? On a graph, you guys know we always end up on graphs. Okay? All we have to do is, if I want to take an image and make it bigger, you just take each value here and multiply it by the scale factor. So if this coordinate is at 2, 3, then multiply by 2 each value, 4, 6. Okay? So you'll see these, it's really simple. Like, they are really nice in the numbers they gave us here. So if I have these coordinates and I want to use a scale factor of 1/4, I'm multiplying every value by 1/4. In what's this the same as multiplying by 1/4? Dividing by 4. So what is this going to become? -2, 1. -1, 2. How come only some of you say it? Like, are the rest of you, like, not understanding? I just want to make sure we understand.
Yeah.
Because sometimes things sound easy in my mind, and then later you're like, I don't understand anything, so I want to make sure. Like, all we're doing is taking these values, every coordinate, if you're going to make it bigger or smaller, and you multiply every value, your x and your y, by 1/4. Same as dividing by 4. This is a really nice one because they pick the numbers really nice. Does it always have to be that pretty?
No.
No. Is it okay, like on your test yesterday, to get decimal answers sometimes? Yes. As long as you do the math right, decimal answers are fine. Okay? Make sense?